This is the fourth in this series. Today we're going to look at the PowerPoint about circles and semicircles. Proceed when ready. Hi, today we're talking about circles. If you hear some noise in the background, someone's doing some chainsawing next door. Anyhow, here we go. We talk about the general equation of a circle. Here we go. Here's this here where we've got the x squared plus y squared equals r squared, where r is the radius of the circle. The thing you'll note here is x has got a power of 2, but also is y. Most of the rules we're looking at so far don't have y of the power 1. So if you see y of the power 2, at year 11 methods at least, you'll suspect that you've got a circle. If we have a circle, and that was where the centre is at the origin, 0, 0. If we have a centre of the circle elsewhere, then the equation will be x take b, so it's being moved b units left to right, just like our normal translations there, and c units left up or down, and r still being the radius, so the centre would be the coordinate bc over the radius r. It's interesting, the centre is actually not a part of the graph of a circle, it's just a point we know that every point on the circle is exactly the radius away from it. Alright, so having been through there's the general thing, let's have a look at some rules here. So the first one says state the centre and the radius of the following. So if there's no number in with the x inside the square or the y, then we'd say the centre is 0, 0. Once again, a good copy of this comes up in the next slide, so you can just watch this, then pause on the next slide and be able to read it a lot better. Here the radius, that's not the radius because the general form of the equation up here, since it's r squared, it's the radius squared, so 25 is actually 5 squared, so the radius of the circle is 5. If we go to the next one then, we can see the x, the centre, x hasn't moved left to right, so it's still 0, but the y coordinate here, now this is because it's inside the bracket with the y, if it's negative 1, it means it's actually moved it up 1. So the centre of this circle is 0, positive 1, and we recognise 49 as 7 squared, so the radius of the circle is 7. When we look at this equation of a circle here, this part here tells me the equation has been moved 4 units to the left, so the centre of the circle is going to be negative 4, and the y has no value inside the bracket, so it's just the circle's been moved 4 units to the left. This here is not one of our perfect square numbers, so we have to work out what the square root of 17 is, and it's the square root of 17. So this is the same as saying square root of 17 all squared. So the radius is the square root of 17. 7's that nice to write with the mouse. Okay, so here's a general circle equation. I recognise the circle's got a squared on the x and a squared on the y. So there's square on the x, square on the y. And this has moved 3 units to the right. And this has moved down 2 units. It's plus 2 in the bracket. So the centre will be 3, negative 2. The radius of the circle will be the square root of this number. The square root of 8 squared is 8. Okay. This time we're doing the reverse of that process. We've got the centre of the circle and the radius given to us. We're asked for what the equation is. So we've decided it's going to be in that form. That's when the centre is at the origin, 0, 0. And part A here, the centre is at the origin, 0, 0. So we could say the equation is x squared plus y squared is equal to the radius squared, the radius is 6, so it'd be 6 squared or 36. You could write either, so you could write 6 squared there if you wanted to, instead of 36. Both are acceptable. This got the centre 0, 0, the radius root 10. So the radius is the centre, it's going to be x squared plus y squared. And that's going to be 2 square root of 10 squared is just 10. Alright, now we've got two equations here with the centre. The first one we've got here, the centre is at 2, 5, so that means it's moved 2 units to the right and up 5, and we're told the radius is 2. So the x part is going to be x. To move it 2 to the right, it's x take 2 all squared plus, so I'm following the general rule up here, it's x plus bracket y, let's move 5 up, so to move 5 we go minus 5 in the bracket, squared equals 2 squared, which is 4. And the last one here, the centre is at negative 3 equals 2, so it's moved 2 to the left and up 2, and the radius is 4. So if it's moved 3 to the left, the bracket would look like x plus 3 squared plus, so that's the general form, it's whatever plus the y part, and the y part's going to be y. If it's moved it up 2, so to be negative 2 all squared is equal to the radius squared. The radius is 4, so it'll be 16. As I said, if we go to the next slide, we'll see a much better version of all these. So that's much neater and easier to read. So you should pause there and make sure your notes have the correct equations in them. Okay, here we've got 3 examples. We're asked to sketch the following and also state the domain and reign of each. Okay, when I look at this first equation here, it says x squared plus y squared equals 1. So from this, I know the centre is going to be 0, 0. And so that's the centre, I'll just write C. And the radius is equal to the square root of 1, which is equal to 1. So from our centre, which is not really a part of the circle, because it's a reference point to work out other points, I have a series of points, an infinite number of points really, which are exactly 1 unit away from it. The easiest ones to mark in is from the centre, you go out 1 to the right here, so the circle's going to go through that point there, which is the coordinate 1, 0. From the centre again, which I'll just mark here, it's not really part of it, I might mark it in a different colour. Here's our centre, 0, 0, it's not a part of the graph though. We need to go 1 in each direction. There's 1 out that way, 1 out here, 1 in all these different directions, but it's easy to stick to straight up. The 4 points that you go straight out to the right, straight up, which will give us this one here, straight out to the left, which gives this point here, 1 unit, and straight down 1 unit. Now, we can write the coordinates of this. This is the coordinates 0, 1. Once again, the next slide will have all this in nice form. This will just explain to you how to get these. And this coordinate down here will be x equals 0, y equals negative 1. Okay, now my chances of drawing a really nice circle with the mouse are almost impossible, but I'll try my best. So I find it easy to start from this point over here and go up and around and come down around like that and around like that. And no one's going to expect you to draw a perfect circle, but I think most people probably draw a better one than what I've just drawn there. Alright, when I look at the next example over here, we've got x squared plus y squared equals 9, so the centre of the circle is at the origin. Okay, and the radius of this circle is the square root of 9, which we know is 3. So So I'm just going to mark in the centre of the circle, which is this point here. And once again, the easy way to do this is to go out exactly 3 units, which will take us here to the right. So it's going to go through the point 3, 0. We go up 3 units from the centre, so we get to here, which is the coordinate 0, 3. From the centre we go out 3 units to the left, so we get to this point here, which is minus 3 on x and 0 for y. And from the centre we go down 3 units, so we get to this point here, which has the coordinate x is 0, y is minus 3. So circle, centre 0, and radius of 3. Now I'll try and draw a proper circle. Maybe I'll start from the bottom point this time, might make it a bit better. I'm happy with that. Should have gone a bit bendier through here. But as I've already said to you, you shouldn't have more than one line. So I'm just going to leave it like that at this stage. Once again, you could probably better actually, it's easier to actually draw as 2 semicircles to one there, and then maybe turn upside down and try and draw the next semicircle. It's a bit hard with the mouse. But you get the idea. The next slide will show you how it should look. Alright, we get to the third example. We can see here the centre of this graph is, let's move 1 to the right, that negative 1 in the brackets, the x, and down 2, because it's plus 2 in the brackets. So the centre that we've got to work with is 1, negative 2, and the radius is equal to 4, because 16 is 4 squared, isn't it? Right, I'm going to mark the centre in, which we said is the coordinate 1 minus 2, which is here. Something like that. And from that, we've got to go out 4 units. So once again, it's still easy to go straight up, straight down, straight right, straight left. So I'm going to go straight across first from this coordinate 1, negative 2. We'll go across 4. I'm going to get to 5, negative 2, which is about here. It's a bit hard to see on my screen here. But yeah, that's near enough. From the centre, if I go straight up 4, I'm going to get to the point 1, positive 2, which is here. And if I go straight left from the centre, I'll get to the point minus 3, minus 2, which is here. And if I go straight down 4 units, I'm going to get to minus 6, 1 minus 6. Right, and once again, I'm going to try and draw this as 2 semicircles, maybe. I had a lot more success starting from the bottom here, so maybe I'll do 2 semicircles and half this way, so that's not too bad. I might go the other direction this time. Yeah, a bit hard there, but you get the idea of what it should look like. Like I said, the next slide will show you how it should look properly. So we're asked to also state the domain and range for each of these. So I'm going to put here domain and range. I might just in this section here, we'll do the domain and range. This might change colour just so for A, the domain is what x values we're using here. All the x values from -1 through to +1. So this is the domain. So for that one there, we'd have square bracket -1 because it actually equals -1 at some point on the graph, and goes across to +1 also equals that. The range of this graph, if you have a look, the lowest y value is -1 and goes up to the highest y value of +1. So the range for part A would also be -1, +1. In fact, the graphs where we find the centre, the origin, these circles, then the domain range should be the same. Right, so in part B, we see that case again. The centre's at 0, 0 here, and the x values, we go from -3 through to +3. So that's the domain of the second one, is -3 to +3, and its range is the same, -3, Always put the most negative number first, so -3 to +3 when using this notation. And square brackets because it's equal to those points. And the last one, this one where centre is now moved off 0, 0, so our centre here was the coordinate 1, 2. So the domain here goes from out here, which was -3, up to +5, so the domain Bowles value is -3 and equal to it, so square bracket 5. The range is the lowest it goes down to the highest it goes up to. So here we can see the range is -6 to 2. All this working out and stuff here will look better on the next slide, so let's go to that now. So now we can see a much neater version. You can see the circles much more like circles in our rough drawings. We don't expect you to draw perfect circles unless you've got a compass. So otherwise just do your best freehand. It's just one single continuous line. Remember that. Okay, that's a good point to stop this slide. In this example we're going to see how we create semicircles. Okay, we're asked here to sketch this rule here, which is not quite like the circle rules we're just seeing. But it's got y equals negative the square root of 36 take x squared. So when we see a square root, with a number minus x squared, this is actually going to be a semicircle. So it's one of those recognition things. If you recognise it, you'll remember it. We've also got to state the domain and range once we draw this. So before we can explain how to draw this graph, we're going to start here and just look at do a bit of manipulation and change the equation so we make y the subject. So I want to make y the subject of this equation here. The first thing I've got to take x squared from both sides. So this becomes y squared equals r squared. I'll just rub that out, sorry. R squared, back to the pen, there we go, minus x squared. And to get y by itself, like the equation above, I can take the square root of both sides, but when we take a square root, we've always got to remember you can get a positive or a minus answer. So we say plus or minus the square root of r squared minus x squared. Alright, there's actually two equations here. There's y equals positive square root r squared minus x squared. Once again, the next slide's got a really nice, neat version of this. You better copy it into your notes properly. Just pay attention for now. And there's two equations. There's the positive square root, and there's also the negative square root of that equation. Right, so if you look back at our original question here, this one here is looking like this. We looked at the form, and so if that was the case, we'd say the radius in this case is 6, and the centre, there's nothing with inside the x or the y, so we'd say the centre is going to be 0, 0. Alright, this gives me two semicircles. This happens to be, if it's a positive square root, this is the top semicircle, and if it's a negative out the front here, this is the bottom semicircle. So we best explain that again. Here's our circle. We can split it in half by horizontally, and this is the positive square root is up here, and this is the negative square root down here. So positive semicircle, negative semicircle. So if I was asked to sketch this graph here, this is the graph I would be drawing. So draw my two axes, x and y. Okay, so I can imagine I've got a circle centre 0, which we've looked at here. So the centre of the circle is here, but It's not really part of the graph we want to draw, so I might change colour for the graph. The radius is 6, so from here we go out 6 units, so it's going to go out to here, 6, 0. We go left 6 units, so it's going to go to negative 6, 0. Okay, because we've got the negative in front of the square root, so here, see here, it's the bottom semicircle. So the semicircle is actually coming down like this and turning back up there like this. So this coordinate here straight down from the thing would be 0, negative 6. And that's the graph we're being asked to draw there. If we had the positive square root, then we would end up with that blue semicircle and be going through the coordinate 0, 6 up there. We're also asked to state the domain and range. So the domain of this graph here, the domain is what XV is. We start out at negative 6 and go all the way through to positive 6. And it's equal to those values, so we use that. This is where we get something different. The range is the most negative value it goes to in this graph is negative 6. Most positive value goes to 0. Okay, so we get a different, these things start to change differently. All right. It says here, find the equation where the origin are. So that's the two that we've got up here, going here, but on the next slide we'll see eventually. And when it's got the centre elsewhere, we'll just give you the rule for that. I'll show you on the next slide and explain what they mean. So here we go to the next slide. All right, so you'll see here that we did the same thing, took the x squared over the other side. Actually, it's got 2 steps in one there. Anyhow, that should just be y equals there. So let's go back on the previous slide. We actually had an extra line in there. So we get two semicircle equations, the positive square root and the negative square root. And the positive square root makes the top semicircle, the bottom. So over here, this is the graph of y equals negative square root of 36 take x squared, which is actually the blue graph here, which is this bit around here. And the dotted one would have been if we had the positive square root. Okay, so that's why the domain we talked about in the previous page is those. So the equation of the semicircle, this is, we should need to highlight these. I'll put them in a box in your notes. Right, these are important. That's what the two semicircles are of the origin, with the centre of the circle at the origin. And if the centre of the circle is elsewhere, then we introduce the values b and c into the equations. And once again, these should be highlighted. It's pretty important. We would expect you to remember those at this point. Okay, we'll stop there and then we'll go on to the example. Okay, I recognise this as a semicircle because even though it's got y equals, I've got a square root, and inside the square root I've got an x value that's been squared. So that tells me that it's a semicircle. Because it's a plus in front of the root sign here, I know it's the top half of the semicircle, so I'm looking for something like this. This 4 here refers to the radius, that's the radius squared, so the radius is equal to 2. Okay, this plus 1 in the bracket means the graph is, the centre of the circle is going 1 unit that way. It's a translation. It should be a 1, shouldn't it? Change it to 1 like that. And this plus 5 here, if you think about it, if it was on the other side, it'd be y take 5. If I took the 5 over to the other side, it'd be y take 5. So therefore, we've moved it up 5 units. So translation y direction 5 units, x direction left 1 unit. So the centre of the circle, originally 0, 0, it's got to go 1 to the right and up 5. So the first thing I do is mark that centre of the circle. That's not actually part of the graph, but it gives us a good reference point. We've decided it's a positive square root of radius 2, so from this point we need to go up 2. So this is a key point on this graph, so we're going to call this negative 1, 7. From the centre of the circle we've got to go 2 out to the right, so we're going to end up at this point here, because the radius is 2. That's the coordinate 1, 5, so that's a key point for us. Tails on it should be just look like a comma. I'll just delete that maybe. Yeah. Okay, and from the centre we go across 2, so we end up here, and that's the coordinate negative 3, 5. There you go. Right, it's a positive square root, so therefore it's going to be a top half semicircle, so try and do your best drawing this. That's not too bad. And that would be the graph that we need to draw here. At this point, we use our calculators to find the y-intercept, or we could find the y-intercept by putting x equal to 0 in the rule. So if you put 0 in the rule, you'd end up with the square root of 4. Take away 0 plus 1 is just 1, squared plus 5. So y is going to be equal to the square root of 4 take 1, which is 3, plus 5. So that's the exact value. You actually have to label it on the graph. That's what you'd use. You'd say when x is 0, y is probably right as 5 plus root 3, the way around. Now the value of root 3 is about 1.73 plus 5, so that means that's going to be approximately about 6.73, which is roughly where going through my sketch there. Okay, we're also asked, always read the question, sketch the graph and state the domain and range. So I have to state the domain and range here. The domain, what x values are used on this graph. Let's see, we start at negative 3 and go all the way across to positive 1, so, and including those, it's negative 3, comma 1. And the range, what's the lowest y value we get to here is 5, so the range is 5, and the highest value is 7. Once again, if you wait to the next slide, you can see a very nice version of this. Okay, so if we go across the next slide now, it's a much better graph there. That nice and smooth, continuous curve. We can see the endpoints of the graph. We can see the highest point it gets to, point negative 1, 7. Notice the centre is not mentioned here because the centre is not actually part of the graph. The graph is only this curve. Like this. The centre, which is here, is not actually on the graph because it's not a part of the graph. And our domain range is worked out for us there. Okay, that's enough for this slide. Here we are, a little applet to demonstrate the calculator with circles and semicircles. So let's have a look. Here I've got, you can change the 3 things that can be changed. Here's where the centre is, the point BC. So we took at the moment the origin is 0, 0 and the radius is 4. So you can see there at every point the radius is 4. But I think I'll move this point around. Where I move to, you can see that every point is exactly 4 units away from the centre. The graph we're trying to draw here though is just the green path followed by that point. The centre of the circle is not a part of it. Okay, so that's a nice little app there. Let's put the grid paper in on the background. So we're looking at the equation of this general form here. X take b all squared plus y take c all squared equals r squared. If I make, say, b1, I'll move the circle across 1 unit to the right. The radius is still 4 because we set the radius at 4 here. So this equation would be written as x take 1 all squared plus y squared, because the CV is 0, is equal to 16, or 4 squared. key points, you can see here we'd be happy with these two key points, but we probably talking about the y-intercepts here, we more talk about the coordinate 1, 4 and 1, -4, straight up and down from the centre. If I make b out to 2, you see the centre now is 2, 0, goes out to 6, 0, goes left to -2, 0, it goes as high as up to 2, 4 and down to 2, -4. If I make c, let's shift the graph down, translate the graph down, say a unit. See now the centre of the circle is 2, -1. The equation here would read as x take 2, all squared, plus y plus 1 all squared equals 16. Alright, we go to the next little map that I've got here. This is for the semicircle. So it's a bit busier. I think I'll just move the graph up, probably make it a bit easier for us, and I'll move back to the origin. I might make a bit small circle, so let's make the radius 3 this time. So I'll just move this over here so that it's the same point, so I'll just put it on top of each other. So you can see that if the radius is 3 and the centre is at 0, 0, the points with the 3's in, so 3, 0, going to the right, straight up, 0, 3 to the left, -3, 0, and 0, -3. The red part of the circle here is the bottom half of the circle. The equation would be y equals negative the square root of 9 minus x squared. Because B and C values are 0, so I'm just saying, right, r is 3, so it'd be 9 r squared, 3 squared, 9 minus x. That be there, so it's just minus x squared, so it'd be y equals minus the bottom half. The top circle, according to this rule up here, the blue one, this would have the equation y equals the square root of 9 minus x squared. If I make b1, you can see the centre of the circle is now moved over here to 1, 0. Radius is 3, so it goes out to 4, 0. Radius is 3, so it goes out to -2, 0. It would go up to the coordinate 1, 3 and down to the coordinate 1, -3. And we'll make c positive 1, so for instance, so now the centre of the circle is 1, 1. Move 1 to the right, not 1. The graph goes out to 4, 1 and -2, 1, and the graph would go up to 1, 4 and down to the point 1, -2. You can see also the y-intercepts there are labelled for us, but not the x-intercepts. Generally we don't worry too much about those unless they're nice values. Alright, the next thing here just shows you the table of values, those. Alright, I think that's a good point to stop this slide at.